The question we're looking at today is from the 2024 Edexcel paper 2. The first 3 marks are more or less standard, whereas the last 5 marks for part B is definitely a bit trickier. In fact, it's very common for students in this actual exam to get 3 and then 0 for part B. I'll quickly go over part A and then we can tackle the tricky bit. So we're looking at a circle, we want to find its centre, we want to find its radius. The main process for this is going to be completing the square from what's given in the question. So of course you can just complete the square as it is, but just to make it a tiny bit simpler, if you're not as confident with completing the square, you could always put the y terms together and the x terms together like this. Remembering completing the square, you are halving whatever is before the x, squaring the bracket, and always minusing. Doesn't matter if this is plus or minus, you're always minusing that number squared. So I'll do it the same for the y. What's half of 14? It's 7. Square the bracket and then minus 7 squared is 49. And then add on 33. And then from here, I'm just going to put all the numbers onto one side. So I'll move all the numbers to the other side, in fact. So 58, take away 33, 25. So that seems like it's going to be quite nice. That's going to give r squared. Remember, this is the general equation for a circle. So as soon as I see 25, I'm quite happy because that means that r is going to be 5. It's not going to be minus 5 because, of course, a negative radius doesn't make any sense. So the radius is equal to 5. And if we compare A and B to what's in the bracket, we get the centre of the circle is at 3. And then this one is the opposite sign, so minus 7. So that's the first 3 marks. Bit more standard, even towards the end of the paper. Nice to get a few marks from this question. Now for the trickier part. It was at this stage that I found the intersection between the 2 circles by subtracting one equation from the other, like you do in simultaneous equations, to find the line which connects the 2 circles. I then used b squared minus 4ac and set that bigger than 0 to say that there are 2 intersections. And it was at this stage that it was taking ages that I thought, you know what, this is clearly not the right method. I just thought it was worth showing because even at this stage, after so much experience, sometimes you do the wrong method and you have to retrace your steps and try something new. In fact, according to the examiner's report, this was the most common method done by students. If you persevere with it, you can get all 5 marks, but to be honest, I gave up, probably made a mistake somewhere in here. It is completely possible, just very, very long process. Let's look at a better solution. I'm going to get a diagram for this. Much easier if I do it in Desmos. What we can see is that the circles intersect. And what I'm doing is I'm currently increasing the value of k. And as k gets bigger and bigger, at some point around here, there are no longer 2 intersections for the circle. So that's going to be the maximum value of k. And at some point, if you make k really, really small, so it's now about 5, and now it's about 4. Again, as soon as it goes below, the circles aren't going to intersect. And that means that the value of k that's the lowest is going to be around about there, which is about k equals 4. Obviously, you can't use Desmos in your exam, but drawing a diagram with what's the biggest case and what's the smallest case where they still intersect could help you out here. So what I've done is I've set up a diagram where k is going to be the smallest possible. The radius here is going to be k. And we know that the radius here is going to be 5. And what we want is that k is going to be small enough such that it doesn't overlap with the 5. What we could do is we could find the total distance from the centre of circle 2 to the centre of circle 1. So the distance, we can use the distance formula here. Take one coordinate and minus the other and square it. And then take the y coordinate and then minus the other y coordinate and square it like this. You can do it the other way around, really doesn't make a difference. We're going to get 9 squared plus 1 squared, which is root 82. So the total distance between the two coordinates will be root 82. But we also know that the radius of the first circle is k and the radius of the second circle is 5. So that means that root 82 must be k plus 5 in the case where the smaller circle just touches. We can then rearrange to get k is equal to root 82 minus 5, and that's going to be the smaller value. Now here's the diagram for the second case, which is not quite big enough to fit on my paper. The distance between the two is still equal to root 82. But this time, the distance from the centre of circle 2 to all the way to the outside is going to be k, because the radius is k. And here, the radius of this, what is now the smaller circle, is going to be 5. Making this diagram a bit neater, the total distance is k, and 82 and 5 are the components which make up this long distance. Well, from this one, we can say that k is equal to 5 plus root 82, or root 82 plus 5 if you like. And that's going to be the bigger value of k for which there's going to be an intersection. You do have to be careful here, because k cannot be actually equal to that value. That would give just 1 point. It would touch it like a tangent. We have to actually make k less than this value, and strictly bigger than this value, because if it just touches once, that's not good enough for the question. The question says intersects at 2 distinct points. That would be 4 marks. To get full marks, we need to put it in set notation. Set notation is really not that tricky. Set notation is like making the inequality nice and warm. Imagine these squiggles are like a coat. You put the coat over the top of the inequality. The coat will always look like this. Squiggle on both sides. And the thing that you want, in our case the k, with a colon next to it, and then just copy and paste this down here. Set notation done. That's the last 1 mark. Using this data from Edexcel, you can actually see that it's a really hard question. Not only is the mean of question from everyone that did it quite low, in the 40%, you can also see the overall mean score is 3.4. So on average, people got 3 marks and then not much more. You can see most people aiming for an A, B, C, all the grades are very close to 3. So people of all abilities were getting around about 3. The A-star students pushed it up to 5, still losing on average 3 marks. Well, there you have it, another question done. Was that the trickiest circle question you've ever seen? Try these questions if you feel like you want a bit more practice, and I'll see you in the next one.